Okay, let's have a look at this. Beam of steel is 2 meters long and is lying on the ground horizontally. The beam has mass of 60 kilograms. Okay. So it's 60 kilograms. So here is 60 G. This is 1 meter. This is 1 meter. And a man lifts it up at one end. Okay. Come on. There you go. Okay. So he lifts it up here with a force F. Okay, so he's turning it anti-clockwise. Okay, he's turning it anti-clockwise, which would be with 2F, and then the weight is turning it clockwise, which would be 60G times 1. And for him to lift it, they must be balanced. So you have 2F equals 60G, so F equals 30G, which is 294.3 newtons. Okay, so the B part. Second man comes to help. He holds the beam 30 centimeters from one end, and the first man holds the beam 40 from the other. What are their forces? Okay, so I guess it doesn't matter too much which way around. So this one here is this is A, this is B, this is 0.3 from this end, and then this is 0.4. So in total that's 0.7, but it's 2 meters long. Okay, so it's 0.6 here, and that will make it to the center, yeah, and then 0.7 here, and it's still 60G. Okay, so we know that A plus B must equal 60G, and if I use this as my turning point, this will be, put it in red, this here will be anti-clockwise, anti-clockwise, and clockwise. So the clockwise must equal the anti-clockwise. So that is 1 times 60G must equal 0.4 times A plus 1.7 times B. So we have this equation, and now we have this one. And 60G. Okay. And 60G, by the way, if you're wondering, is 588.6 newtons. Okay, let's see. Okay, so we want to solve this. Okay, so I'm not going to go through the steps because we've seen plenty of these in maths class. So when solving these two, we get A is 317 newtons, and then B is 272 newtons. Okay, now part C, 2 men hang the rope, 20 from each end. Now you can actually do this one the same as the last way, if you like, but actually, because it's symmetric, we know that these must be the same, because this is the same, and this is the same, and this is the same, and this is the same. So in fact, we have here just 2t equals 60g, so t would be 294.3 newtons. Okay. Now gets different. Man A puts his 5 kilogram tools 10 centimeters from one end of the beam, and man B puts 1 kilogram 10 from the other side. So now there's an extra 5 here, and there's an extra 1g here. Okay, so now in this picture, these won't be the same anymore. These will become different. So let's redraw that. Okay. Keep it the same. Okay, distances 0.1, 0.1, 0.8, 0.1, 0.1, 0.8. Okay, so we have t plus s equals now 66g. So t plus s equals 647 newtons. And again, the turning forces, so let's see, clockwise, 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 anti-clockwise, anti-clockwise. So we have 0.1 times 5g plus 1 times 60g plus 1.9 times 1g must equal 0.2t plus 1.8s. So we have 0.2t plus 1.8s. That must equal 60g plus 1.9g plus 0.5g. So that will be 612 newtons. So again, not too difficult to solve. Okay, so solving those two give 345 newtons for the first answer and 302 newtons for the second answer. So the last part of the question now, the beam is like this, and we still have our two ropes. But this time we're told that the tensions are equal. The weight is still down the middle here, 60g. And the toolbox down the end is still here, of 1g. But now the other box has moved. The lunch is still there and the other box has moved. So we'll just put it like here, but we don't know where that is now, so I'll just call it x. Right, so the two up forces, t plus t, 2t, that has to equal 66g. So that's nice, that gives us the t, be 33g, which is 324 newtons. And now again, if we look at the turning forces, this should be able to give us our x. So now we have x times 5g plus 1 times 60g plus 1.8 times 1g. That should equal 0.2 times t plus 1.8 times T. So let's see what that is. Okay, so that's 647. Let's see. 266 minus 1.8 minus 16 times 9.81. Okay, so we end up with 5gx equals 41.2. So we end up with x equals 0.84 meters, which would be around about here. Let's see, 2. Good, okay, so when the first man slides his toolbox over, when it is right here, the tensions will be equal. And then when it passes here, the tension in the second rope will increase. And before it reaches this point, the tension in the first rope will be bigger.